This is question 20 of the Unit 1 Physics booklet. And we have got a light ray. Let's draw a little diagram here. We have got a block, and in this block we have got a light ray that's going that way, and this is our normal. This is the air, this is the glass, and we've got an angle which is 30 degrees. There we are. Okay. And refractive index of the glass, n equals 1.49. So, part 1, calculate the angle of refraction. Well, what's going to happen to this? This ray of light is now going to speed up, so instead of coming out like that straight away, it's going to bend away from the normal. So our angle here is going to be larger than 30 degrees. We've got an equation, n equals sine I over sine r. For the ease of the maths, I'm going to imagine this light ray is actually going the other way, and that our angle of incidence is there and refraction there. You can juggle about with the maths and get it the other way around, but in order to calculate this angle, this is the way I'm going to do it. So let's rearrange this equation because we want I on its own. So n times by sine r equals sine I. Just going to turn that the other way around. N times by sine r. The sine I equals n, 1.49 times by sine r, so sine of r, which is 30 degrees. Because 1.49 times by sine 30, so sine of 30 is 0.5. Times that by 1.49, that gives us equals 0.745. And if we do the reverse sign of that, that gives us, so that's still sine I, so I equals sine minus 1 of that equals 48 degrees. So this angle here is 48 degrees, and that makes sense. It bends away from the normal because it's going into air now. Part 2. Complete the figure shows what happens to the ray, so we've done that. That's part 2. Part 3. Calculate the critical angle. Well, we've got n equals 1 over sine c, and we're just going to arrange that to find c. So n times by sine c equals 1. Sine c equals 1 divided by n. So let's put that in. So equals 1 divided by 1.49. So 1.49 our refractive index. So 1 divided by 1.49 is that number there, 0.67. So sine c equals that. C equals sine minus 1 of that. Shift sine minus 1 So our critical angle is 42 degrees. On the figure, draw the complete path followed by that leaves at the critical angle. So that is, so I'll draw it in red. So a light ray hitting this and then not refracting through and not reflecting but going that way. So that's part 4.